Hello everyone. I would like to continue with the previous video that we factor 4x squared minus 27x plus 18, and we end up with the two binomials multiply with each other as x minus 6 multiply 4x minus 3. And in that video, I kind of mentioned that one of the questions that the student asked me, I've heard this question many times, that instead of writing negative 24x, subtract 3x here, is that okay to write subtract 3x, subtract 24x? Okay, so the magical part is we still end up with the two binomials, and we still can factor it out by finding our common factor, and here they call factor by grouping. Okay, so let's examine that. So instead of writing, so let me rewrite the entire expression again. So instead of writing negative 24x and then negative 3x, I'm going to alter their position. Okay, so let's say I will put 3x squared, and then I put minus 3x minus 24x positive 18. Okay, and then I go group them again. So you see that it doesn't matter the position or the place for either you put negative 24x or negative 3x. They still can have a common factors among this group. And then when you pull them out as factoring by grouping, you still end up with the same binomials. So the first two terms, your common factor would be x. Okay, so then inside the bracket, you end up with 4x minus 3. Okay, so now you are taking a look at negative 24x plus 18. The common factor here would be 6. Okay, so it would be 6. So, but you want to take out a negative 6. Okay, so the negative 6. So what you have inside here, you should have 4x left, right? So 4x times negative 6 will give you negative 24. And since you take out the negative 6, you should end up with a negative 3 inside the bracket. You see that? Okay, so make sure that you kind of be mindful of the number that you want to factor out. So in this case, you should factor out a negative number so that it will reduce another step, reduce a complicated step. So if you take out the positive 6, you end up with negative 4x plus 3. Then you still have to factor out the negative 1. Okay, so at the same time, make sure that you factor out the negative number. So the products of these two, negative 6 times negative 3, give you positive 18. So you see, this is your common factor. And then you pull out that common factor. Then what you have left, there is x minus 6. And this actually the same. You see that? So because of the product, the position of these two are not that important, because it's the product of two numbers. You expect the same thing. So here, x negative 6 multiplied by 4x minus 3 inside the brackets is the same thing as you just write 4x minus 3 multiply x minus 6. Okay, so it doesn't matter of the order for the when you break this middle term into two. All right, so let's continue with our next example. And this example, the number is actually getting even bigger. Okay, the number is getting even bigger. Once we are taking the a times the c, our number is really big. So I will take 12 times negative 12. Okay, so don't forget involving the negative in front of this as well. We give you negative 144. And then I have to write down negative 7. All right, so now I'm going to show everyone a bit of the analysis. okay? But you can analyze all of this number. You are very close to the solution already, okay? So you are having two numbers multiplied will give you negative 144. But that same two number adding will give you negative 7. So think about this, okay? So if you have a negative product, so that means your number, the two numbers multiply with each other, one of it has to be a negative value. And that negative value will have to be the absolute values of that negative number will have to be higher than your positive number, so that the result will take the negative sign. Okay, so let me repeat that. Okay, so once I get the result, I will show you what I mean by that. Okay, so if you're adding two numbers and you end up with a negative, that means the absolute value of your negative number is bigger than your positive number. Okay, so now negative 144. So like I said, try to divide until you can not divide anymore, or even catch the number that very much related to this number that you have. So you can estimate it. Okay, so here I have negative 144. So if you take that and you divide it by 2, so try with the positive number first, and then you add in the sign later. You're adding the sign later, either negative or positive later, because you know that in here you must have a positive and a negative number. And here your negative number is absolute value of that negative number will have to be higher than your positive number. So I take 144 divided by 2, what do I get? You can use a calculator to try this as well. You got 72. Is 72 and 2 somehow related to your 144? No. So keep on dividing. Take 144 divided by 4. You end up with 36. Is 36 and 4 related to 7? None. Okay, so then you want to take 144. You divide it by, let's say I divide it by 6. Okay, I end up with 24. 24 and 6, they are not very close at all. Okay, so 144 divided by 8, I got 18. 18 and 8, it has nothing to do with the 7. Okay, so 144, let's say you divide it by 9, you got 16. 16 and 9, the relationship could bring you to the 7, right? So that means now you are going to decide the sign for it. So this will be 16 times 9. Is that right? Okay, 16 times 9 gives you positive 144, but you want a negative. So you are going to assign this negative to a bigger number. Why I'm saying that? Because the absolute value of negative 16 is equal to positive 16 and is higher than 9. So the trick here is this, right? So therefore, when you take negative 16, you add that with 9, you end up with negative 7. Okay, so that's why I was saying the absolute value of 16. So this is the absolute value here of 16. Will be a positive 16, and positive 16 is greater than 9. So your negative number, its absolute value has to be greater than your positive number in order for your result to take the negative sign. Alright, so after we got this, we can break this into 2. Okay, so now I will write 12x squared minus 7x minus 12. So I'm going to break this into 2 by writing 12x squared subtract 16x plus 9x subtract 12. Okay, so double check. This 2 adding will give me negative 7x. So I got it correct. Now I'm going to group the 2 terms. Okay, so the common factor for the first 2 terms is 4x. Okay, so it's 4x. Right here I should have 3x minus 4. And in here I should take out the positive 3. So it will be 3x minus 4 left inside the bracket. So now this 2 will be my common factor. So I will pull it out. And what do I have left? It's just 4x plus 3. Okay. So the same thing, if you write the 9x at the front and the negative 16x at the back, your answer should still be the same. Except that you will have 4x plus 3 multiplied by 3x minus 4. Alright, so it's always a good idea to check, right? So why don't we double check by expand our term to see that we end up with the same original result that given to us, the original statement here, the original expression. So we are going to get this time this time this, time this, and time this. So I should have 12x squared plus 9x minus 16x minus 12. So right here I should have 12x squared. Combine this term, I should have negative 7x and minus 12. So I got it correct. Alright, okay, so I will leave it for you to perform the step where you are writing the 9x before you write the subtract 16x, and your answer should still be the same. Okay, so let me go over my chart here for everyone regarding the special product. I just want to quickly remind everyone about the special product and their factors. So this is our difference of square, right? Difference of square, then the formula will be a minus b, a plus b, and the expanded form for this is actually a squared minus b squared. Because if you multiply this in like this, so let me demonstrate this for everyone. So if I take that, multiply that, I will have a squared minus ab plus ba minus b squared. And notice that this and this is actually the same, okay? And they are cancelled out because b times a is the same as a times b, and this actually cancel out. Okay, so I can make a note here that a squared minus ab plus ab minus b squared, these two terms cancel. So I end up with the a squared minus b squared. So that's why a minus b, a plus b are the factor of the difference of square. But if you have a plus b inside the bracket square, then your expanded form will be like this. A plus b times a plus b, according to the definition of the exponent, right? So exponent tell you that if you have a base raised to a certain power, then you have to multiply the base by itself. How many times according to the number of your power. So if you expand this, you are having a squared plus 2ab plus b squared. So a minus b all of it squared. The expanded form with a plus b, a minus b, a minus b. Then when you expand it, you are having a squared minus 2ab plus b squared. So I would like you to note the difference between the three. The differences between the three, which I found many students make a mistake, is they think that a squared plus b squared perhaps equal to this, but it's not. Okay, a squared plus b squared is just a squared plus b squared. It's totally different from a plus b all of it squared. Since a squared plus b squared all of it squared, you have to expand it, it's equal to this. You have the twice the product as a middle term here. So therefore, if you have a squared plus b squared, it's just equal to a squared plus b squared. There's no special formula for this sum. Okay, so if you have something like this and you need to factor, you can say that it's non-factorable. Okay, so if you have a sum of the two square, you cannot factor them any further unless you have a common factors. Okay, so now I want to conclude that a to the exponent n plus or minus b to the exponent n is not equal to all of this inside the bracket square. So these are the common error that many students seem to make an error. So I think it's a good idea to mention it here. Okay, so I want to clarify with a few example. First of all, I have 25 subtract x squared. Okay, I can go ahead and do this. I can go ahead and write 5 squared minus x squared, right? So then I have 5 minus x, 5 plus x. Everyone agree, right? Because this is the difference of square for me. But then what happens if I have 25 plus x squared? Can I expand this? Can I factor this? I can write 5 squared plus x squared. And then that's it. Okay, that's it. I showed you that line and that's it. You cannot expand them any further. Okay, so the difference here is if I have 5 squared plus x squared, but now I don't want to write this. I write it, all of it in the bracket square. How do I factor this? I just have to apply the very simple definition of power. If I have a base raised to this power here, then all I have to do is just take a look at the power and multiply the base by itself according to the number of my power. So my power is 2, so I multiply the base by itself twice. So it's just like you write a squared equal to a times a. Okay, so in this case you have a plus b, all of it square. It means you just write a plus b times a plus b. The same thing. If I have a 5 minus x, all of it square, it will be equal to 5 minus x multiplied by 5 minus x. Okay, so I really want everyone to recognize the difference. Don't assume that the a square plus b square is equal to this. It's not. Okay, so see my proof here for you. If this raised to this power, its factor will be this. Its factor will be a plus b times a plus b. Okay, so factor is the products of something. So this is the product. Multiply this product will give you this. And its expanded form will be a squared plus 2ab plus b squared. So that's why we are talking about this as a special product. The name for this is a special product. So the expression is this. Its factor are these, and its expanded form are these. So the expanded form of the a squared minus b squared is the exact same thing. But its factor will have these formulas that we have to remember. A plus b, all of it squared, will be a plus b times a plus b, and its expanded form will have this twice the product in between as a positive. A minus b, all of it squared. Okay, so that means its factor will be a minus b, a plus b. If you expand it, this 2, you end up with this trinomials, and there's a minus the twice the product of your middle term. Okay, so these are the common error that most that I have seen students make error for the past few years, many years that I'm teaching. Not few years, many years. I have to say that I'm entering my 27 years of teaching. 25 years at Niagara College and 2 years at Mohawk College. I believe that I've seen that mistake quite a few times. So anyway, thank you for listening to this video, and I would like to conclude our video right here, and to remind everyone that this video is the number 3. Okay, this video is number 3 in all the for the entire lesson to introduce everyone about factoring. And the factor we are dealing with is the greatest common factor, common factoring, difference of square, factoring trinomials, and special products. Okay, so there are 3 videos altogether. So I have done from common factoring till we are having factor by grouping. So this is very much related to the method that we are using to factor the trinomials. And I also try to show everyone the meaning behind the factoring. Okay, because we have done it so many times and then we forget. We forget that if we divide a number into an expression, okay, into a term in the expression, if we divide, then we must multiply, or else we alter the expression. And the original expression is not the same. So when you factor, these are the behind step. Okay, this is proven right away like this. You should apply this in terms of factoring complicated binomials. All right, okay, and then we move on to the difference of square. Difference of square, that means you have a square subtract another square. So in this case, we work with perfect square in order to factor. Okay, so there's that we have. And in order for us to do this, we should remember some of the formulas for exponent as well, because they are related and they all apply to this question. And we can always check to see if our answers are correct. Okay, so now you see the expanded form of the difference of square, the exact same as its original expression. Okay, then we some of the difference of square. The perfect square may not be obvious, so you really do have to try common factor first, and then the perfect square will review itself. And in this case, even if the exponent 4 is also the perfect square, because y squared raised to the exponent 2 will give me y to the exponent 4. Okay, so it's a spiral of exponent here, but it's still applied to our factoring. Okay, and then we factor trinomials when a is equal to 1. And this trinomial that we are dealing with has a form of the quadratics. Okay, so the factor for this trinomial in the quadratic form, the result will be the product of 2 binomials. And our variable x will be the same, but the 2 number will have to be found by finding 2 number. Adding those 2 number will give you the middle term, which is the b, and the product of the 2 numbers will give you the number c. And in the end, it should always a good idea to check. Okay, so this is pretty simple in terms of a equal to 1. But when a is not equal to 1, then we have to take the product of a and c. Then after that, we can figure out the number. So once you found the 2 number, you are breaking this into 2. Okay, so over here, I think I should say that I should write on here that 9 times 4 give me the 9 plus 4 will give me 13. Okay, so I should put this here for everyone to see. So that's why I break the 2 middle term into this, and then from there we can do common factor and then factor by grouping. In the end, we should check our answer. Okay, in the end, we should check our answer. And I did this question as well, but I expand a little bit more into does it matter the order, whether or not I put subtract 24x and subtract 3x? I can alter its position, then what happens? So when I alter its position, I still end up with the same 2 binomials as the factor, except that the order is different. But in terms of product, the orders is still representing the same thing, right? So 2 times, let's say example, 2 times 3 still give me 6, but 2 times 3 still give me 6 is called it's one of the properties of algebra. All right, okay. So for this question, the number is quite high, but I show everyone a trick how to figure out the 16 and 9, and then attach a negative sign with it, and you know that you have to attach a negative sign to the bigger number, which is negative 16, because then the sum of this will give you a negative value. And again, break them into 2, and then find common factor, and then group factor by grouping. At the end, we check as well. And here we are talking about special products and their factor, so that we can avoid the errors of thinking that a minus b all of it squared would be similar to a squared minus b squared, because a squared minus b squared is called the difference of square. Okay, then a minus b all of it squared is the difference of two numbers and all of it square. Okay, see the brackets here? In mathematics, every little thing counts. Okay, so that's the thing about mathematics. Every little thing counts. Everything has its meaning. So the beauty of mathematics is you just cannot throw in a bracket for no reason. You can, but it's not like decorative or it means something. Okay, so the brackets in here showing that it's significant, meaning that you must take a minus b first before you can square it. You see, still go back to the very basic of math math, order of operation. Okay, this one is also goes back to the basic of math math, which is order of operation. So you have to square first before you subtract. You see the difference between here? You square first before you subtract. This one inside the brackets, you subtract first, then you square. So they are totally different. All right. Okay. Then this one is called the sum of square, but we don't need to say that because we don't have a formula applied to the sum of square. A square plus b square is just a square plus b square. There's no special formulas for the sum, which I indicated here, and it's totally different from a plus b all of it square. See the same concept applied to bad math. You have to follow order operation. That's a very basic rule in mathematics. So in this case, you square the number before you add them. This one, you add the number before you square them. All right. So I hope all of this will conclude our basic understanding for greatest common factor, common factoring, factoring trinomials, and how it's related to the special square. All right. So I will end the video here. I will put a link below this video, how it's related to the other two, how the three videos should come together. All right. Thank you, everyone.